Okay guys, today we're going to talk about neutralization reactions. Before we start, you're going to need a couple of things out. Your Chapter 11 guided notes, please have them out. There's a lot to fill out through this lesson. And also you're going to need a calculator. So please, if you're watching the video, make sure you have access to a calculator. Alright, so here is a neutralization reaction. When we have an acid and we react that with a base, it's going to neutralize each other and it's going to form water. What's the pH of water?
7.
Yeah, the pH is 7. That's why it's called a neutralization reaction. You form water, but you also form salt. Okay, before I start, everyone thinks that salt is always NaCl. That is a salt, but there's many more types of salts. What a salt is a metal and a nonmetal. So, yes, sodium is a metal, chlorine is a nonmetal, and this is a salt, but it's not the only salt that there is. So neutralization reactions are very important. What if I spilled a really strong acid on the counter? What could we react it with to neutralize it? A base. And that's because, guys, if you remember the pH scale, it goes from what to what?
14.
Yeah, 0 to 14, and right in the middle is what? 7. This is neutral. So if I had an acid that was down here on the pH scale, it was very acidic, and I spilled some of that acid, I could neutralize it by reacting it with a base in this region. And where's it going to meet? Where's the pH going to meet? Right in the middle at 7, and that's why they're called neutralization reactions. Here's some examples. This first example is HCl. Is this the acid or the base? Hopefully you can recognize this now. This is the acid. Most of the time acids will start with a hydrogen, but not always. We know that this is the base because it's got this ion. What is that ion called?
Hydroxide.
Hydroxide. Good. The acid will donate the hydrogen and the base will accept it. Well, when this hydrogen comes over to the hydroxide, what does that make? That makes water, and that's where the water is coming from. Well, what's left for this sodium and this chlorine? Well, their partners left. So what they do is they form a chemical bond. The sodium comes over here and hooks up with the chlorine, and that's where the sodium chloride is coming from. Same thing here. This is sulfuric acid. It donates its hydrogen to the base, which is potassium hydroxide. The hydrogen and the hydroxide meet up. They form water. What's left? Well, the potassium got left, and so did the sulfate ion. So this potassium comes over, hooks up with the sulfate ion, and makes potassium sulfate. So one thing that you might have noticed, both are switching partners. What kind of chemical reaction is that? Double replacement. So like it says right down here, all neutralization reactions are double replacement reactions. So that means they're both going to switch partners. Okay, acid-base neutralization. Here's an example problem. It says in each of the following reactions, identify the salt that would form. So I want you guys to be able to identify what the salt will be from these reactions. Remember, if we have an acid and a base and we mix them together, it's going to form a salt and water. So we know one of the products has got to be water, which is H2O. The other product, whatever is left over, is going to be the salt. So let's see if we can do this problem. First of all, which one is my acid, which one's my base? HCl is the what?
Acid.
Is the acid. And the sodium hydroxide, if it's got hydroxide, obviously it's going to be the base. Okay, well, we know that the acid is going to donate the what? What does the acids donate? The hydrogen. So this hydrogen is going to be donated, which means given away. The base is going to accept it. That hydrogen comes over here, forms a covalent bond with the hydroxide ion, and what does it make? It makes water. So how do we know what the salt is? It's simply what's left over. The sodium now has no partner, and the chlorine now has no partner. So the sodium will come over here and hook up with the chlorine. So what is the salt going to be? Now, here's where students kind of get confused a little bit. Do you list the nonmetal or the metal first? The metal always comes first. So real easy, if it's listed first, keep it first. If it's listed second, keep it second. Okay, let's see if we got this. Practice problem 13. It says in the following reaction, identify the salt that would form. So I want to give you guys a chance to try this one. If you're watching the video, please hit pause at this point and tell me what the salt is that would form here. Once you're done, hit play and see if you got it right. Okay, hopefully at this point you've tried it. But this H2SO4 is going to be the acid. We see hydroxide here, so that's definitely our base. Well, the acid donates its hydrogen to the base. The hydrogen is being donated to the hydroxide, and that's forming the water. So the salt is going to be what's left over. Now, the calcium doesn't have a partner, and neither does this SO4, the sulfate ion. So the calcium is going to come over and be in front, so my salt is going to be calcium sulfate. How many of you guys got it right? Okay, very good.
Does it not matter how many?
No, we're not concerned about balancing it in this one. Just identify the salt. Good question. Yeah, we're not going to balance them.
Will you ever balance them?
If it told us to balance it, then we could, couldn't we? But yeah, don't worry about it in these practice problems. We're just identifying the salt. Good question. Okay, number 14. Again, same question. I want you to identify the salt. So if you're watching the video, please hit pause at this point. Once you have your answer, then hit play, see if you got it right. Okay, so let's see how you did with this problem. HNO3 is our acid. It starts with H. KOH is our base. It's got hydroxide. That's definitely a base. So the acid is going to donate its hydrogen to the base, and it's going to make the water. That's where the water is coming from. Our salt is what's left over. This potassium got left, and this NO3 got left. So what they will do is hook up and form the salt. KNO3. Potassium nitrate. How many of you guys got it? Okay, very good. Number 15, exactly the same type of question, but now a different chemical reaction. Again, I want you to identify the salt that's going to form. If you're watching the videos, please hit pause and try to get it on your own. And then once you have your answer, hit play. See if you got it right. Okay, so let's see how you did with this one. This H2CO3 is the acid. The NaOH is our base. The acid donates its hydrogen to the base, which makes the water. The salt is going to be left over. We have sodium ion and the CO3 ion. The sodium will come over and form a bond with the CO3. So the answer there, the salt is NaCO3. Okay, I've got one more question with these types of problems where you're identifying the salt. So let's see if you can do it one more time. Please hit pause if you're watching the video and try it on your own. Once you have your answer, hit play. See if you got it right. Okay, so in this case, the H3PO4 is our acid. The CaOH is our base. So the acid is going to donate its hydrogen. The base will accept it. When that happens, that forms water. The salt is what's left over after the water is formed. And so this calcium ion and this PO4, the phosphate ion, will be left. The calcium comes over and forms a bond with phosphate. So it's called calcium phosphate. How many of you guys got it right? Okay. Very good. Hopefully that gives you some practice, and now you feel confident about predicting from a neutralization reaction, an acid and a base, when they react, you can predict what is forming the water, and you can predict what salt would form. Okay, I had some extra practice problems in here if we needed, but I feel like you guys know how to do this, so we're going to skip through the extra practice problems here. Okay, let's talk for a second about when complete neutralization occurs. If you were to spill an acid on the counter, how would you know when it was completely neutralized? How would you know when it was completely neutralized? How could we know that? Can you look at an acid-base solution and know its pH? You can't just look at it and tell its pH, can you? What if we had a test strip, though? Complete neutralization would occur when the pH of the solution was what? Was 7. Okay, so we need to know when the pH of that solution is going to be 7. Well, here's when that happens. Complete neutralization occurs when moles of the acid equals the moles of the base. So if you spilt 5 moles of acid, how could you completely neutralize that?
2 moles of base.
Yeah, the same number of moles of base. So if you spilt 5 moles of acid, you'd want to put 5 moles of the base on. Okay, here's an easier way of saying that. Moles of H plus has got to equal moles of hydroxide. Because H plus makes things what? Acidic, and hydroxide makes things basic. So if we could calculate how many moles of H plus was in the solution, would we then be able to know how many moles of hydroxide you have to put on it?
Yes.
Sure. And that's what we're doing. Okay, the neutralization formula makes this process very easy. So here is the neutralization formula. Please write it in your notes. And we'll talk about the variables here in a second. Okay, so we've got MAVA is equal to MBVB. Now let's talk about what these variables represent. What is capital M in chemistry? Molarity. So the molarity of the A represents what? The acid. So we're going to take the molarity of the acid, times it by the volume. V is for volume of the acid, and set that equal to, what does M stand for? Molarity of the base times the volume of the base. Okay, I wanted to explain how this works, the mathematics of it. Molarity isn't molarity. How do we calculate molarity? Moles divided by liters. So that's M. What do we get if we times that by V, which is liters? What do we get if we take moles over liters times liters? Won't the liters cancel out? And so you're left with moles of acid. Well, you do the same thing on the other side. Molarity is moles over liters. And if we times it by the V, which is volume in liters, again, they cancel out. And so moles of acid equals moles of the base. Okay, so that's how the neutralization formula works. It's figuring out the moles of acid and the moles of base and when they will be equal. So let's try using this neutralization formula. It's going to be very important that you know how to use it. So practice problem 17. I will go through this one with you, but I've got a bunch more that are going to follow this that you will do on your own. So please watch and write down everything that I write down. Okay, practice problem 17. It says, how many liters of 2.5 molar solution of HCl are required to exactly neutralize 1.5 liters of a 5 molar solution of sodium hydroxide? Here's how I do chemistry problems. I like to underline what they give us. So they're giving us, and I want you guys to do this too, the molarity of the acid here. So underline that. They gave it to us. They also gave us the volume and the molarity of the base. So let's underline that. Now I like to circle what they're asking us to find. What are they asking us to find? How many liters? So really, what is that? That's the volume, right? They're asking us for the volume. Now, one of the things that can be complicated with these problems is figuring out which one is the acid and which one is the base. HCl is what, guys? This is our acid. Yeah, it starts with an H. Most of the time that's going to be the acid. But look at the base here. It's got hydroxide in it. That's a dead giveaway that this is the base. So please write that in your notes. Now that I've read the problem, I underlined what they gave us, we circled what they wanted us to find, let's write the neutralization formula. What was it? Cal, what was it real fast? MA equals MB VB. Okay, perfect. That's an easy formula to remember. Now we just got to plug in what they gave us and solve for the missing variable. It's that easy. Did they give us the molarity of the acid? Yeah, 2.5. This capital M means molarity. So 2.5 goes in for that one. Did they give us the volume of the acid? They didn't. That's actually what we circled here, was the volume of the acid. And I'm just going to call it VA. Just going to keep it that. Okay, let's set that equal to, did they give us the molarity of the base?
Yeah.
They did. What was it?
5.
Was it 1.5 or 5?
5.
Yeah, it's 5. How do we know that? This M right here is for molarity, so that's 5. And we're going to times that by the volume of the base, which was what? 1.5 liters. Okay, very good. Now it's a simple math equation. We have one unknown, so we can solve for it. What would you guys do first? 5 times 1.5? Okay, let's do that. 5 times 1.5. So I keep everything on the left the same. 2.5 times VA is equal to 5 times 1.5 is 7.5. Now what would you do? Yeah, we want to get VA by itself. How do we get this 2.5 off that side?
Divided.
Yeah, the only way to get rid of it is to divide it by 2.5. Now, do I have to do it to both sides?
Yeah.
Sure. It's an equation. That's what the equal sign means. You have to treat them both the same. So 2.5 over here. My 2.5's cancel out on the left. And so 7.5 divided by 2.5 will give me my answer. So the volume of the acid is equal to exactly, did you guys get 3? Okay. 3 what though? 3, this is volume, so it's going to be liters. And we really should write what acid it was that we were talking about. 3 liters of what? HCl. Yeah. All right, so I hope you realize what we just figured out. If you spilled 1.5 liters of a 5 molar concentration of base, we can neutralize that, which means go to a pH of 7 if we put a solution of acid that is 2.5 molar and the volume of 3 liters. If we mix that with it, it would neutralize it. Okay, practice problem 18. I want you guys to try this one on your own. Go through the same steps that I just showed you. If you're watching the video, please hit pause right now. Try to get an answer here. Once you have an answer, hit play, see if you got it right. Okay, so let's see how you guys did. What I would have done was underline what they gave us. Okay, it looks like they're giving us these numbers here. And circle what it is they wanted you to find. This was the same type of question that said how many liters. So we're looking for a volume. Now let's identify what the acid is and what the base is. KOH. Is this the acid or the base, guys? Here's a hint. It's got OH in it. This is the base. So please write that next to KOH. My other solution was HCl. Is this the acid or the base? This is obviously our acid. It starts with H. Okay. Now, let's write the neutralization formula. MaVa is equal to MbVb. Let's plug in our variables. Did it give us the molarity of the acid?
Yes.
It did. The acid, remember, was HCl. So the molarity was 0.1. So 0.1 goes there. Let's times that by the volume of the acid. It said we had 3 liters. So 3 goes in there. It's equal to the molarity of the base. Did it give us that? Yeah, right here, this. Whoops, so 0.2. That's the molarity of the base. And the volume of the base. Did it give us the volume of the base?
Yeah.
And that's what it wanted us to find, was how many liters of this base, so we don't have it. Okay, let me show you another way to solve this. If I wanted volume of the base to be by itself, I want to isolate that variable. How do I get rid of this 0.2?
Times the left side and then divide it.
Good, yeah. Let's divide it by 0.2 on both sides. Okay, over here it cancels out. And so on the left side, if you take 0.1 times it by 3 and then divide it by 0.2, you will have your answer. So 0.1 times 3 is 0.3. Now divide that by 0.2. And VB, the volume of the base I'm getting was 1.5. 1.5 what? Liters. 1.5 liters of what? We really should put what the substance is, and our base was KOH. So that's your answer. How many of you guys got that right? Okay, very good. Now let's move on to practice problem number 19. This one is a little bit different. So I would like to go through this one with you. Okay? So let's read it. It is a little bit different. When 50 milliliters of a HNO3 solution is exactly neutralized by 150 milliliters of a 0.5 molar solution of KOH, what is the concentration of HNO3? What do you notice that's different? Yeah, milliliters. So I want to talk about that as we go through this problem. But let's underline first what they gave us. 50 milliliters of HNO3. They gave us 150 milliliters and 0.5 molar of KOH. And they're asking us, what is the concentration of HNO3? So please do that in your books. Underline what they gave you. Circle what they're asking you to find. Now let's decide which one's the acid and which one's the base. This HNO3, what do you think, guys? Acid or base?
Acid.
Yeah, it's definitely our acid. It starts with hydrogen, and we know for sure because our other substance has KOH in it. OH is definitely going to be the what? The base. Okay, so now we've got that identified. Let's write the formula for the neutralization. Neutralization formula is what, guys? Perfect. Okay, let's substitute in. Did it give us the molarity of the acid? Or is that what it's asking for? That's what it's asking for. So I'm just going to keep calling it Ma. Did it give us the volume of that acid?
Yeah.
It did. But here's how it's different. Could we convert this to just liters?
Yeah.
We could, but we don't have to. If you keep them the same on both sides of the neutralization formula. So if it's 50 milliliters, let's just keep it as 50 milliliters. But just make sure that the other side also has to be in milliliters. Okay? So equals. Did it give us the molarity of the base? Yeah, it did. 0.5 molar was the base. Did it give us the volume of the base? 150. Now, is this in milliliters as well? It is. So I can keep it in milliliters. But what if it said 50 milliliters here on the left, but then it gave us liters over here? Would we have a problem? Yes, you would have to convert to like units, either both milliliters or both liters. Okay, so just keep them the same on both sides and you'll be just fine. Okay, what should we do to solve this? Let's do 0.5 times 150. What is that? Isn't it 75, guys? Okay, so MA times 50 is equal to 75. How do I get MA by itself? Divide by 50, both sides. Okay, it cancels out there. And so MA, the molarity of this acid, would be 75 divided by 50. Did you guys get 1.5?
Yeah.
Okay. 1.5, what should I write though? What's the units? Capital N for molarity. And what was the substance? What was the acid? Wasn't it HNO3? It's nitric acid. Okay, very good. So just remember, if the units are the same, guys, guess what? Milliliters goes here and milliliters goes here. What happens when you divide milliliters by milliliters? It cancels out anyway. And so if they're the same, you're going to be just fine. Just keep them in the like units. Okay, practice problem 20. This is the last practice problem in this lesson. I want you guys to solve this one. Okay? So if you're watching the video, please hit pause at this point. Once you have your answer, hit play and see if you got it right. All right, guys, let's see how you did with this problem. What I would do, underline what they gave us. So let's find those numbers that they actually gave us, underline them, and circle what they're asking us to find. It says how many milliliters. Okay, so that's what we're looking for. Now let's identify the acid and the base. H2SO4 is an acid. It starts with hydrogen. That usually it means that it's going to be our acid. But we know for sure because BaOH2, hydroxide in it, this is our base. Guys, H2SO4, just real quickly, is one of the most abundant acids made. This is one of the most famous acids in the world. It's called sulfuric acid. It's used all the time in a lot of different industries. So H2SO4 should be one that you just recognize and know its name. It's called sulfuric acid. Anyway, okay, let's get back to the problem. Once we have everything underlined and circled that we want to figure out, let's write the neutralization formula. MAVA is equal to MBVB. Now let's substitute in. Did it give us the molarity of the acid? So this was our acid up here, and it gave us the molarity right there. So 0.6. Did it give us the volume of that acid? Nope, that's actually what it wanted us to find. So I'm going to call it VA. And just keep in mind, it wants it in milliliters. We better have those units in the end. Is equal to, what's the molarity of the base? Yeah, set it right there. So 0.3 is the molarity of the base. And what was the volume of the base?
100.
Yeah, 100 milliliters. And that's good that they gave it in milliliters. How come? Yeah, then we won't have to convert it in the end. We will be in milliliters already. Okay, so what should we do now? Okay, take 0.3 and times it by 100. What does that give you? Move the decimal over 2 times. That does give you 30. Now, how do you get VA by itself? Good. Divide by 0.6 both sides. Cancels out on the left side, so VA is by itself. So the answer is going to be 30 divided by 0.6. So VA, the volume of this acid, has got to be, did you guys get 50?
Yeah.
Okay, 50 what? Milliliters, yeah. Because this side was measuring 100 milliliters, that means this side will also be in milliliters, so we know that. And we really should list what the acid is. What was the acid? H2SO4. And yeah, what's the name of H2SO4? Sulfuric acid. Very good. Okay, guys, hopefully that helps you understand neutralization reactions. When we have an acid and react it with a base, you're going to meet somewhere in the middle in terms of the pH scale, right at 7, hopefully, if you do it just right. And that's why they're called neutralization reactions. To give you some more practice with this, in your student workbooks, there's a worksheet, and it's titled Neutralization and Titration Worksheet. Now, you're only going to be able to do the first half of this worksheet where it's talking about the neutralization reactions. So please go there. Again, it's called the Neutralization and Titration Worksheet. Let's get that done, and hopefully this video helped you.